Welcome to this explainer. Look, if you want to efficiently build a fast-track foundation in JavaScript and, turn yourself into a confident developer without wasting time, you are in exactly the right place. We're going to cover the fundamentals from the ground up. We'll move quickly, but I promise we are going to be incredibly thorough. So right off the bat, we actually have to acknowledge a direct quote from our source material. It says, overall JavaScript is a bit of a weird programming language. There's a lot of kind of weird things that go on. And honestly, they hit the nail on the head. We are going to enthusiastically embrace this weirdness today. JS has these fascinating little quirks and gotchas that literally trip up even veteran programmers. But by the end of this explainer, you're going to know exactly how to navigate them.
Okay, here is the exact roadmap we're taking today. First, intro and setup. Second, variables and types. Third, logic and control flow. Fourth, functions and arrow syntax. Fifth, objects and arrays. And finally, a quick preview of part 2. Let's dive in.
Section 1, Intro and Setup. Running Hello World. So, before we even write a line of code, we need to understand that JavaScript is essentially the behavior language of the web. Think of it like this. If HTML is the structure and CSS is the paint job, JavaScript is the engine that actually makes the car move.
Now, JavaScript code needs an environment to actually run. Usually that's just a web browser. You can embed it right into an HTML file using a script tag, or, even easier, just pop open your browser's developer tools and type code directly into the console. But it absolutely doesn't stop there. Thanks to Node.js, JavaScript runs on backend servers too. Now, wherever you run it, your go-to output tool is going to be console.log hello world. For basic browser interactions, you've got built-in pop-ups like alert, prompt, and confirm. But hey, listen up. Here is a massive rule of thumb. Always put use strict in quotes at the very top of your scripts. It opts you into modern parsing rules and instantly catches silent errors, like, say, assigning a value to a variable you haven't even declared yet. It is an absolute lifesaver.
All right, Section 2, Variables and Types. Building blocks. Let's talk about how we actually store data, because building a rock-solid foundation definitely starts with variables. So in JavaScript, you've got 3 ways to declare variables, but they are absolutely not created equal. The old school way is var. Now, var is function scoped, and it's what we call hoisted. That means the declaration conceptually moves to the top of the function before the code even runs, which, trust me, leads to some super unpredictable behavior if you access it too early. Modern JavaScript, we rely on let and const. These are block scoped. They only exist within the specific curly braces where you define them, like inside an if statement. Now, const stands for constant, meaning you cannot reassign that identifier later. So the golden rule here, just use const by default. If you know the value has to change later, use let. Basically, just pretend var doesn't even exist unless you're untangling legacy code. Moving on to data types. JavaScript has 8 basic ones. 7 are primitive, and 1 is complex. We've got strings for text, numbers, which gracefully handle both decimals and integers, and booleans for your classic true or false. Then we have 2 different types that basically mean emptiness. Undefined means a variable has been declared, but hey, nothing's been assigned to it yet. Null, on the other hand, is when you explicitly want to say, this is empty on purpose. And oh man, here is a fantastic piece of JavaScript weirdness. If you run the code type of null, JavaScript actually returns object. No way, right? It's an infamous legacy bug baked into the language. They can't fix it now without breaking millions of older websites, so we just kind of laugh and memorize it. We also have big int for ridiculously massive numbers and symbols for unique identifiers. And finally, the object type, which handles all our complex data structures. Section 3, Logic and Control Flow, the danger zone. Pay close attention here, because we are entering the danger zone of type coercion and conditional logic. Let me ask you a provocative question. What happens when you combine different data types? If you write the code 1 + 1, what do you get? Well, you get the string 11. Why? Because it sees the plus sign, and JavaScript just implicitly coerces that number into a string and squishes them together. But what about 6 + true? You actually get the number 7. Since true isn't a string, JS tries to mathematically convert it, and true evaluates to 1. This is called implicit type coercion. It's super powerful, but if you don't know what's happening under the hood, it will literally create absolute chaos in your code. Which brings us directly to how we compare values. JavaScript gives you loose equality, which is a double equal sign, and strict equality, which is a triple equal sign.
Loose equality attempts that sneaky type coercion we just talked about before it compares things. So that means 1 equals 1 actually evaluates to true. An empty string equals 0, true. And null equals undefined is also true. As you can imagine, this is a massive source of bugs. The fix? Always use strict equality, the triple equals sign. Strict equality checks both the value and the data type. So 1 equals 1 is correctly identified as false. Now, when you're writing conditions, you really need to understand falsy values. In JavaScript, 0, an empty string, null, undefined, nan, and false will all evaluate to false in an if statement. Literally everything else is truthy. Yes, even a string containing the number 0 or a completely empty array. We use standard logical operators too, like and, or, and not. But watch out, the and or operators don't just return true or false. They actually return the operand value itself. So if you write hello or true, JavaScript returns the string hello because it's the very first truthy value it bumps into. We also have this great thing called the nullish coalescing operator, that's the double question mark, which safely provides a fallback only if the value on the left is strictly null or undefined. As for control flow, you've got your standard if, else, switch statements, plus your classic for and while loops. Section 4, Functions and Arrow Syntax, the core of JS. Okay, let's move to functions and see how this all builds together, because JavaScript handles them pretty uniquely compared to other languages. Beyond standard function declarations, JavaScript heavily relies on function expressions. This is where you literally assign a function directly to a variable, like const greet equals function, empty thing. Now, because it's tied to a const or let variable, it is not hoisted. You absolutely cannot call it before you define it in your code. The cool thing is, JavaScript functions are incredibly flexible. You can pass them as arguments into other functions, you can set default parameters so there's a backup value if a user forgets to provide one, and you can even use rest parameters to scoop up an infinite number of arguments into an array. But here's where it gets really interesting. Let's break down arrow functions versus regular functions. Honestly, this is probably the most commonly confused topic for beginners. Arrow functions give you this sleek, compact syntax, but they fundamentally change how the this keyword works. A regular function? It gets its own this context based on how it's called. So if a regular function is living inside an object, this refers to the object itself. But arrow functions do not have their own this. They inherit the this from the surrounding scope where they were defined. This is a massive pitfall, guys. If you try to use an arrow function for an object method, like a greet function, and try to return this.name, it won't point to the object. It's going to point to the global window scope, and it'll just return undefined. So the rule of thumb? Always use regular functions for object methods and save arrow functions for callbacks where you specifically want to preserve that outer context. Section 5, Objects and Arrays, Structuring Data. Next up, we're tackling how to neatly group all this information using complex data structures, namely objects and arrays. So arrays are ordered, mutable lists, and you create them with square brackets. They come packed with incredibly powerful built-in methods. You can push and pop items to the end of the list, or use functional methods like map to transform every single item, filter to pluck out specific items, and reduce to boil the entire array down to one single value. Objects, on the flip side, use curly braces, and they represent key value pairs. You access an object's properties using dot notation, like user.name, or you use bracket notation if the key needs to be dynamic. Now, modern JavaScript gives us some truly elegant ways to handle these structures. Destructuring lets you effortlessly unpack properties from objects or elements from arrays straight into their own distinct variables. And the spread operator, which looks like 3 little dots, ... is a total game changer. It unpacks the contents of an array or object. You can use it to instantly merge 2 objects together or quickly create a copy of an array. But, big warning here, the spread operator only creates a shallow copy, meaning if you have an object nested inside another object, spreading it just copies the memory reference to that nested object, not the actual nested object itself. And that brings us to a super crucial concept. Objects and arrays are assigned by reference, not by value. If you assign array A to array B and then you modify array B, well, surprise, you are actually modifying array A as well, because under the hood, they are pointing to the exact same spot in your computer's memory. This is exactly where those sneaky mutation bugs love to hide. Now, luckily, JavaScript does have automatic garbage collection. It just quietly deletes objects from memory once nothing in your code is referencing them anymore. When you're working with objects, you are also going to love optional chaining. It's this question mark dot q dot syntax that lets you safely try to read deeply nested properties without completely crashing your program if a step in the chain is missing. Oh, and of course, you can easily convert any of these objects into strings for sending across the web using JSON stringify.
Beyond your basic objects and arrays, we also have maps and sets. A set is absolutely brilliant when you need a list of uniquely guaranteed values. Duplicates are just automatically ignored. A map is kind of like an object, but it allows literally any data type to act as a key, whereas standard objects only allow strings or symbols. And this really illustrates the depth of JavaScript, because it also gives us weak maps and weak sets. In these weak versions, the keys must be objects, and they are held weakly. That means if there are no other references to that key object left in your program, the garbage collector will just automatically sweep it away. This makes them perfectly designed for caching temporary data without causing massive memory leaks. Pretty cool, right? Section 6, Code Quality, Pro Habits. Before we wrap up this foundational tier, we really need to talk about how the professionals maintain clean, bug-free code. It really comes down to 4 essential habits. First, you've got to master debugging using your browser's developer tools. Just hitting F12 and stepping through your code line by line is vastly superior to just wildly guessing where the bug is. Second, write clear comments that explain the why behind your code, not just the what. Third, professionals use automated tools, things like ESLint to catch syntax errors and Prettier to enforce consistent styling across the whole dev team. And finally, they implement polyfills and transpilers, like Babel. Basically, these tools take the shiny, modern JavaScript syntax you just wrote and automatically translate it backwards into older JavaScript syntax. That ensures your cutting-edge web app is still going to run perfectly on someone's 10-year-old browser. Section 7. Preview, the next level. Wow, okay, you've made it through the core mechanics and built a really solid foundation. But trust me, there is so much more to learn in this language. In part 2 of this explainer series, we are going to conquer the advanced concepts. We'll explore closures, which leverage that lexical sculpting we touched on earlier. We'll build object-oriented structures with modern classes. We're going to dive deep into asynchronous JavaScript, using promises and async-awaits to handle data fetching. And finally, we'll learn how to take all of this logic and use it to physically manipulate the HTML on a web page through the browser DOM. So you have survived the quirks, the weird type coercions, and those infamous arrow function pitfalls. You now have the JavaScript foundation. The only question left is, are you ready to master the web? Join us in part 2 to take your skills to the absolute next level.